is the content of my presentation. It's going to be a 1 hour presentation, so I will keep it as interesting as possible so that you won't be falling asleep. So I will do an introduction on the applications on Geogrid in various ways. Then I will go into introduction and some details into the projects that we have done in Singapore, so that just to give you the confidence that this material has been approved by the authority in Singapore and has actually been physically applied in the projects. Then I will conclude for the presentation. So first one, introduction of the application of Geogrid. Now, what is Geogrid? So you have seen all the black colors surface material that you saw just now in all the pictures. So what is actually Geogrid? So Geogrid is considered as a type of bigger category called geosynthetic products. So it's black color because it's made from high density polyethylene and also polypropylene. So like the one you see, this is one of the sample of the Geogrid. Like the one you see in the bottom corner on the slide. This is called IE series of the tensile material. It is actually made from high density polyethylene, which is HDPE in short. So you might have seen HDPE in many applications, such as used to making gas pipe and so on. So it's the same material that we use to produce Geogrid. So it's a very durable material. And polypropylene is the one that we use to make the tri-X material that you see on the middle bottom of the slide that is in the triangular shape. So the method of producing this is by punch and stretch method, which means the material actually comes in one whole continuous piece. So how you get this shape is basically by punching hole in the HDPE or polypropylene sheet, and then they stretch it by the certain technique in the factory to produce this, so that they actually are all continuous piece of material. So this strip here is produced by basically stretching the material after you punch the hole. So this method of producing this can make, therefore making the material very durable and have very good properties. So it is very good for use in stabilizing of embankment and stabilizing of pavement, which I'm going to show you more later. So the main functions I would like to emphasize again is for reinforcing of a soil structure, such as soil slope and wall, and also stabilizing of the ground to create a pavement on a very soft ground even. I'll show you a video later just to illustrate what I'm trying to say. So next slide here, you can see the various applications of Geogrid in various photo. You can use for subgrade stabilization to stabilize the subgrade so that you create an access road into a site that has very soft ground. And you can also use for optimizing the pavement for road, for even for highway. And then you can use for asphalt reinforcement, making an even stronger road to reduce the maintenance frequency of the road, and to make and this one, as you can see my mouse, right? So this one on here is, you can see, is what we call the tensile tech earth retaining wall. You can this facing is actually concrete panels, precast concrete panel, and internally is actually this Geogrid that is actually placed horizontally. Then you can see that there's track bed reinforcement using the tri-X, and embankment building using the structural material, and even used for erosion control system, as we have another type of material that is similar to this, but it's actually covered with another type of geotextile that's acting as a filter material that actually can use to filter as a filter and to be used for erosion control. Okay, so this slide is to show you that actually this product has very long history, and it has actually been approved in the Europe and obtained in various DBA and IOTA test recognition. So it's a very recognized product and widely used in the community. And not just Europe, sorry, it's around the world. And they have actually shifted their manufacturing plant to China, Wuhan. You know about the COVID-19 case. So Wuhan the operation there has been actually disrupted for a while. and now they are all back in operation. So the supply of the product is all back to normal. So we are now able to get this product from Wuhan as usual. Now, this is a common problem that you see on the road pavement. So actually, by using geogrid reinforcement to stabilize this pavement below the asphalt, you can actually prevent this from happening. You know, when this has happened, it's very difficult to rectify, because even you take out the pavement and you try to repave the asphalt. After a while, this crack will come back, because it's not just the pavement problem, it's not just the asphalt problem, it's actually the subgrade problem. So you need to really stabilize the subgrade before you can actually make the pavement stable and lasting. So this is another different problem of pavement, as you can see, and all this actually can be solved by proper design of the pavement by using geogrid stabilization. Now, this is the mechanism that is helping to stabilize the pavement, be it asphalt pavement, or it's just a normal access road pavement with those hardcore material, temporary access. So the reason why the geogrid is able to stabilize the pavement is that the load distribution coming down from the wheel, as you can see from the arrow, is actually a circular loading, and it's actually aimed to be spread in a circular manner. But if you do not have a proper reinforcement to distribute this load evenly, of course there will be stress concentration, right? So when the stress concentration happens, you will see a cave-in after, or rutting we call commonly, when the wheel is keep running on the same path. Yeah. So by having this triax material, which we are not talking about single axle or biaxial, we're talking about triax, which means the grid are in a triangular pattern. By having this grid, the load distribution, as you can see, on the right of the screen, because of the arrangement of the grid in a triangular pattern, the load is able to be distributed very evenly, so without any stress concentration. Whereas on the left, you can see if it's a biaxial way, which is the conventional geogrid, other supplier do not have this property. As you can see that it's only strong in the axial direction and the two axial direction, but you'll be weak in the diagonal direction. So if it happens that there is a loading in the diagonal direction, the capacity of the load taking will be reduced greatly, and therefore this is a weakness of the grid, and eventually rutting and settlement will happen because of this. So by having the triangular grid pattern, this problem can be resolved. And to actually create this triangular pattern, it requires actually a lot of research and technology to actually come up with a method, manufacturing method, to actually stretch it in a certain way in the factory to produce this. Just as I said earlier, the production for this geogrid are all from a continuous sheet of membrane. In this case, the triax is a polypropylene membrane, which comes with a continuous sheet. So it's actually produced by punching hole and then stretch in a certain manner and with a certain strength to produce the grid. So it's a very strong and continuous grid. And this grid of triangular pattern actually come in different sizes to suit different type of loading. Now, here I'm going to show you a video just to demonstrate what I said earlier, how effective is this triax stabilization when there is and when there isn't. So this truck I'm going to show you here, this truck is going to run through a part of the road that has already been reinforced with Geogrid Triax TX 160 and with a granular thickness of 300 mm on top, and this is done. And after that, the truck is going to run onto a road that is not done, that's not reinforced with the tensile geogrid, and you'll see the difference. So now it's running on a pavement that's already been stabilized by TX 160. You can see you hardly see any settlement at all, just with 300 mm thick of the granular material and with the TS 160. And then yeah, this is the part that is not reinforced with the tensile geogrid, but has the same thickness of the granular material, and totally the ground is not able to take it. So basically, the granular material that you pave on top will be totally lost and submerged into the ground without, if there is no there is no placement of this tensile geogrid to stabilize the material. So you can see how important and how effective is the tensile in stabilizing the pavement. So this is a comparison of the pavement design when we are using tensile triax to stabilize the subbase compared to one that does not have the subbase stabilization. So what I'm going to show you here is actually to show you the potential that we can actually reduce the thickness of the subgrade of the pavement, and this will potentially save a lot of cost and also reduce CO2 footprint, because you reduce the amount of material of the surface you need to transfer in from a foreign place, and also you reduce the amount of material you need to excavate and export out to other places. So you reduce a lot of carbon footprint and also the cost and also the time in constructing the pavement. So, but not to worry, I'm not going to go into details of the design for the pavement. So what I want to highlight is that there is a great potential saving by introducing triax material into pavement design, and that will actually create a longer lasting pavement, and when we are constructing it, it's cheaper, safer, and faster, and reduce carbon footprint. So it means you make it more sustainable. Yeah, this is the slide that I want to show about the benefit of using tensile to reduce the thickness of the subbase for pavement, which it can potentially reduce a lot of carbon footprint by reducing the transportation of material in and out of the site. By having lesser subbase, lesser granular material that you need to put below the asphalt material, by having this reinforcement, it actually reduces a lot of carbon footprint. Now, how it managed to do that? Why this geogrid is different from others is because of the triangular grid. Now, having this triangular grid, it not just reinforce, it's not just acting as a reinforcement, it's actually acting as a net to actually capture all the granular material together to prevent them from moving when the wheel is running on top, when the load is running on top. So it basically introduce an additional interlocking effect, interlocking mechanism to this granular to actually make them stronger and more stable. So that is the principle, and that's why we can actually have a reduced thickness of the granular, and yet the pavement can still be lasting longer. Now, so this is a slide to show you that again. By using the triax, is actually a potential cost-saving products, and also it will reduce the time in delivery. Most importantly, it is sustainable because it reduces carbon footprint. Now, next, I will cover the very common feature that we use in Singapore, which is to build retaining wall along the highway, next to condominium projects. So commonly you see is vertical RC retaining wall, which is very ugly. I think even as a civil engineering, I also think that it is undesirable. And if you are a landscape, architect, for sure you will hate this. So how to do away with this? Do we have other alternative to build RC, to build retaining wall, vertical retaining wall, other than using reinforced concrete retaining wall? Yes, the answer is yes. So the answer is using tensile geogrid. Now, so this one you see on the screen now, you see almost vertical slope, which is as good as a wall, right? So if we do it in a conventional way, you will see a row of RC retaining wall, ugly RC retaining wall alongside the road, because actually there's another road on top, so there's a two-layer road. So to separate the two-layer road, because of the level, there need to be embankment. So this embankment in a conventional way will be a RC retaining wall, so it will be very ugly. But with the use of Geogrid reinforcement, we can actually build a very beautiful green wall. We eventually, after it's built, grass grow on it, you hardly realize that there's a retaining wall there. So that's the beauty and the magic of using Geogrid to build retaining wall in this manner. Singapore is starting to adopt this in some of the projects, which I will show you later. And we call it green slope or bioengineering slope, as per the term used by the landscape architect. Now, this is another one that is used in this, if I'm not wrong, is in somewhere in Europe. I can't tell you where. So it's a very high wall used as some kind of defense purpose. So it's again, you can see that behind you can see some grid, right, material. So those are geogrid, and behind the geogrid there are some kind of geotextiles that's actually wrapped around to prevent soil from losing through the roots. So those actually, those behind the geogrid, those actually come in bags, and you can build a very high wall. This wall is as high as 12 to 15 meter high and almost vertical. The angle is about more than 70 degrees, and we can actually make it vertical by having a facing material. Yeah, so this really has great potential for use as a retaining wall, and then by the time it finished and the grass grew on it, it will just look very beautiful, and you will not realize that there's a wall there. Now the next application is the use of the Geogrid in building a fully vertical retaining wall, but in places where we do not allow any angle, any even slight angle at all, we will use this kind of building techniques to have either a sandbag facing in front or even interlocking block facing in front. Then we can actually make it look standing vertically and beautiful, and without any you don't feel there's a concrete, because the interlocking block will just basically look like the texture will basically look like rock. So you will be basically seeing a rock rubber wall rather than a RC retaining wall. So behind this interlocking block are the again this kind of geogrid that's placed horizontal. Now, so this is just one of the examples that we quoted from Tensar, the data provided by Tensar. So in one of the projects, they have actually done a cost comparison and carbon impact comparison. So in this project for hospital, they use a modular block here, which is here, to build the retaining wall instead of the conventional RC retaining wall. So they realized that the project cost dropped by 50%, more than 50%, and the carbon impact has also reduced by more than 50%. So it's just, this is just an idea for your reference and how significant is the reduction. And the photo you see now is use of the Geogrid with interlocking block and acting as a retaining wall and also as a bridge abutment. So you do not need to have, you do not see the ugly pile and column standing in front of the pile of the bridge when you are crossing the bridge under the highway, right? So by having this beautiful wall wrapping around the bridge abutment, and you can actually take the load from the bridge beam, and then we just need to design for it. So it provides a great alternative for bridge designer and highway designer to come up with nice and beautiful bridge abutment and also landscape around the highway. This is another photo showing the interlocking block I used to construct the bridge abutment with the combinations of this Geogrid, and it's beautiful. This is just another photo taken from another angle for the same bridge. Okay, second, so there's all the general applications for Tensar Geogrid. So in general, I have covered with you is pavement, use of the Geogrid in pavement, and use of the Geogrid in the retaining wall or green slope, and also the use of Geogrid in the beach apartment. So even with these three potential usage, and you can see that these are very common design items in our projects in everywhere. So if you can apply Geogrid in all this area, you can make the environment greener, definitely. So next, I'm going to show you some of the projects that we already completed in Singapore using Tensor Geogrid. So the first one I want to show you is actually an ABC water project in Tampines. So we are actually using Tensor Geogrid to build a green slope or bioengineering slope in the ABC water project. This is, I think, I need not introduce this. This slide, you should know better than me. Okay, so this slide shows you that actually this project was covered in IES magazine cover story and also featured in the cover page in the latest IES magazine, the May 2020 issue. So in this cover story, it briefly describes the project, the ABC water project, and using the Geogrid material to form the bioengineering slope, and it's really come out to be very beautiful and very effective. So the next few slides, I'm going to show you how we actually do it and some of the site photos for your reference. So I think this is a very interesting project, and that's why we managed to get it featured and covered in IS. So this is the site location. It's actually located in Tampines. So the existing river is actually a concrete line canal, and the plan of PUB is to upgrade this canal and make it into an ABC water project. So we got to create an effect, something like this, which has green slope next to the river. And we have to make the river as natural as possible and as accessible to people as possible. Now, this is the slope that's actually one of the part of the trial slope that actually we have done before we do it in the large scale. So if you can see the design of the slope is in twofold. One is with the reinforcement using this tensile Geogrid, and then in the facing we actually using another type of smaller type of Geogrid to actually with a geotech style covered to actually act as a facing to prevent the loss of material and also a filter to make sure that only water can come out and not the soil. So and then we also we also have discussed with the landscape architect to how to actually plant various plants into the slope to let it grow effectively on the slope and not to drop out. So if eventually we have a system to make this green slope after many rounds of discussion, and it was successfully implemented on site. So these are some of the photos. And here you can see that although the Geogrids are very useful in terms of application, but the packing and the logistic of this Geogrid is very simple. So it is basically it is like this, but actually it can come in roll up. So the transportation and the logistic part of handling the Geogrid is actually very easy. So you can actually get just one worker to handle, two workers to handle a single row of Geogrid and without any problem. And in terms of transportation, you also save a lot of CO2 footprint because it can be compacted very effectively. Now, after the rows are laid out, this is how it's seen on site after it's been rolled out. So this is the view that you will see before it's actually compacted with the soil on top. So after we lay the material, then we will start to compact a layer of the soil layer by layer on top. And then we make the facing, and then we start to grow the plants on top. So it's a very simple. So eventually, this become the river channel, and you cannot. In this case, you do not see very ugly concrete facing on the river lining. Then what you see is all green. And when it's just in the dry weather flow, you basically see a green slope. Only when there's a storm then the slope will be flooded with stormwater. But after the stormwater is gone, the slope will be there again, because the reinforcement and the facing material will actually protect the soil. So this is the initial stage when all the plants are planted, and then when it was shown to be okay, and then we actually planted for the whole stretch. So so this is the ABC projects that we actually use Geogrid. And then just want to thanks PUB for allowing us to publish this material and also present this material to the public and publish in the magazine. Thank you very much, PUB, for giving us this opportunity to actually apply this material. And at the end, all of us were very happy that it was very successful. Okay, the next one I'm going to show you is the use of a Geogrid for slope embankment. And this is also a PUB project. This is in Woodleigh, where Woodleigh water. This is in the Woodleigh area, where they actually have a new plant to be built, and then because of the service road is very close to the highway, there need to be a steeper slope to be built. So in order to make the slope stable, if you do not use Geogrid, you will end up with an RC retaining wall. You will build an RC retaining wall, and then to make up the higher level. But we came in, and then we proposed Geogrid reinforced slope in order to replace the ugly RC retaining wall. So this is a 3.9 meter high steep slope, and the ground conditions is not so ideal. So that's why we need to. It was very carefully designed and ensure that we do not encounter any problem after the construction. So this is the ground condition. It's actually fill material at the ground level before we top up the 3.9 meters. So fill followed by Kalang formation, followed by overlay. And the Kalang formation was found to be normally consolidated at the time. And therefore, we actually had some kind of surcharge for about 3 to 6 months actually before we construct the slope in order to prevent any consolidation second. So this is the slope that we actually design. We provide reinforcement onto the slope to build the slope so that it's able to withstand the steep angle without failure. So if in the normal slope without the Geogrid, I think you will not be able to stand. Definitely there will be slope failure with this kind of angle. So with the use of Geogrid, we actually use the RE series, which is this in the Geogrid in the slope reinforcement, and we have done the analysis. So that's why we are able to provide a one-stop solution for contractor and for consultants, because we are able to use our consultant office to do the analysis and design to come up with the best design for you, and then we will use our trading office in hub to actually do the logistic part of the material supply to cater to your needs. So then we can actually give you a total solution. So this is a good example of showing you how we provide a one-stop service to solve a problem by avoiding the use of RC retaining wall and create a green slope eventually. So this is a location where we actually build the slope, and this is a bigger section on where the reinforcement will actually use and how the slope are formed eventually. So we actually top up 3.9 meter high with a steep angle of the slope. Now this is the photo showing the progress of the slope. So again, we lay the Geogrid horizontally and with enough embedment length, and then we will actually compact the soil, and then we build layer by layer. So this is a photo showing the progress of the Geogrid wall construction, and you can see after it's constructed, the slope initially is bad, but after a while, if you go and see now, it's totally green. Now you cannot see the Geogrid material anymore. So that is the beauty of using Geogrid reinforcement in the slope. Now, next one, I'm going to show you a case history that is actually very interesting. It's a very special application of Geogrid, and this is further to demonstrate to you that with proper design and planning, you can actually use this Geogrid material in a way that you can never imagine. Yeah? So I'm going to show you how. So this is a reinforced slope. It's a reinforced slope, but it's used in a very special way. So we actually, in this project, we are actually required to build water pipe in the marina area. So this is actually part of the Marina East Desalination Plant project, where we actually have to do a lot of temporary excavation work for pipe laying. So in one of the particular case of the pipe laying, we actually require to maintain a slope within the excavation. Yeah. So but the slope need to be a very steep angle within the excavation. So this is not a permanent slope. It's just a temporary slope. So in order to sustain the angle of the slope, we eventually design a geogrid reinforced slope within the deep excavation ERSS. So it's a very interesting application of geogrid. This is eventually how it looked. We actually provided a lot of we provided the geogrid, which is again RE. We use RE series for the reinforcement, and then we do not actually provide any facing. You can see the soil actually exposing from the soil. It's actually exposing, but in this case, we are not so particular about erosion. Because it's within the excavation site, so we just need to maintain the stability of the slope. So this is a very special application. And then we also have another case. We apply this in actually many areas in the same project because we found that it's so convenient to be used to form a steep slope within the excavation by using the reinforcement. And we also use it in another way in the same project to actually protect the pipe. So because this pipe is being laid under the reservoir, under the seabed of the reservoir, so we actually wanted to protect the pipe from dredging and from potential scouring. So instead of using the conventional armor rock, we actually use geogrid wrapped around the sandbag, acting as a reinforcement to provide the protection to the pipe. So you can see the application of geogrid is really up to your imagination. So some of the photo showing that the section showing that after we actually excavate down to lay the pipe, we then build up the protection before we actually this protection is built up with geogrid before we actually backfill back. So this pipe is actually fully encased in the geogrid reinforcement. So it's very interesting for that project. Now, next one, I will show you also a very interesting application of geogrid, which is also in Singapore. In this case, we actually use the geogrid to build steep slope embankment for ground improvement work, such as you want to pre-consolidate a ground with prefabricated vertical drain PVD. You need surcharge, right? So normally to maintain the surcharge, you need to maintain a very gentle slope. So because of this gentle slope, it has a lot of edge effect that is not desired by geotechnical engineer in doing the consolidation work. But there's no choice, right? You either build a very expensive retaining wall to have a clear cut edge, or you let the soil actually slope down naturally, but it just takes up space. But sometimes you do not have the luxury of the space for the surcharge to actually slope naturally down. So such as when you're doing ground improvement work near the airport area, in the Changi area, you do not have the luxurious space because actually the space is very constrained over there. So therefore, we come up with this geogrid reinforced embankment. By using the geogrid reinforcement, we're actually able to build a very steep angle embankment, and this will actually solve the edge effect for the consolidation for the ground improvement work. So I'll show you how. So this is the purpose of the slope. We're actually trying to reduce the space required for the slope. So we have to make the slope steeper because the general typical angle is 1 vertical to 2 horizontal, which is very gentle. So we do not have the luxury of space. Therefore, we need to have a steeper angle, and therefore we use the reinforced soil concept by using geogrid reinforcement. So this is the schematic showing how the embankment slope will look like. So generally, we will we will have, for example, we have PVD, prefabricated vertical drain, all below the ground here, and then we need to have a surcharge to actually consolidate the ground for about half a year, 9 months usually. So in the normal case, we will, without the reinforcement, the backfill will have to have a very gentle slope out. So imagine if this is a 12-meter high slope, 1:2 angle for the normal backfill, you end up you require another 24 meter all around the edge just to let the slope down, right? So definitely you do not have the larger space of 24 meters. Therefore, by having this reinforcement, it basically solves that problem. You cut out the 24 meter space, it basically let the slope stand almost vertically, close to vertical. We can have up to 70 degrees, and actually this is very effective for the PVD work, PVD surcharging work. And to prevent erosion from the face, we are using jumbo bag or just actually normal sandbag to place at the facing. But with that means at the wrap around of the geogrid here, basically we have a sandbag inside when we are wrapping around, so to prevent the sand from actually losing through the face. So it's just a very simple mechanism to create a filtration effect. So this is the details on how we do it. You don't need to worry about this. If you need to know how to, if you have a project, you need to know how to do it, you just contact us. We will come to you and discuss with you all the details. This is just some of the site photo that we are doing the trial. This is the sandbag that I just mentioned. So the sandbag was actually used at the face for the geogrid to wrap around to act as a filtration effect to prevent sand from losing through the face. So the construction was so easy that you just need simple excavator and few workers to actually lay the geogrid, carry the sandbag, and then do the soil compaction, and that's all. So we did the trial, and the trial was this is the small trial that we do. You just need workers with a compactor to compact the soil layer by layer, and then after that just wrap around after you place the sandbag. So it's very, very simple in terms of construction, and that's why we can very confidently say that it actually really helps you to save a lot of time and cost in your construction, because you avoided the use of heavy, large equipment, large machineries. And you see, even the workers, they can actually do the cutting everything easily by just normal scissors. So they can do all the laying and very easily, because overlapping, there's a standard procedures that we have in the SOP in the construction of this. So workers just have to follow. So after a few rounds, they will become very skilled in doing that. So this is how it looked like with using the sandbag, or we call it jumbo bag, to do as a facing for the geogrid to be wrapped around the face. So this will prevent the soil from being lost from the face. All right, so that's all the application, and all these few applications that I show you for the past 30-40 minutes are all in Singapore. So we have actually already been actively applying the geogrid in Singapore, and I believe before this there could be other projects that you may not be aware that's already been using this geogrid. So there is really a wide applications of geogrid in the civil engineering project and also in the landscaping works. So in the conclusion, we just want to stress that the application of geogrid is definitely an alternative to the traditional construction techniques that is really worth considering, because it can really reduce your overall carbon footprint, especially associated with construction activities such as transportation, trucking soil and material, and also the need to use heavy machineries and so on. And yet it provides additional performance, and it meets the basic performance in terms of durability, in terms of the required strength and movement. But on top of that, it actually provides you additional beauty, additional benefit of having the beauty of nature. Basically, it allows you to see a green slope or green wall at the end of it, and you do not need to live with a concrete facing concrete surface for the end product.